September 16, 1940. Fort Benning, Georgia. Lieutenant Colonel George S. Patton stood in the motor pool, watching a convoy of 63 military trucks prepare for maneuvers across the Tennessee Valley. The 2nd Armored Division, which he now commanded, was about to conduct the largest mechanized exercise in American military history. But Patton wasn't watching the tanks. He was watching the trucks, and what he saw disturbed him profoundly. Of the 63 vehicles lined up that morning, 41 were civilian models hastily painted olive drab. 17 were 1938 Chevrolet 1.5-ton commercials with wooden stake beds. 12 were Ford Model AA trucks designed for delivering bread and milk. 8 were Dodge Brothers panel vans built for department store deliveries. 4 were International Harvester farm trucks, still smelling of fertilizer. The remaining 22 were a mix of military prototypes, no two identical, each requiring different parts, different maintenance procedures, different training. Patton walked the lead truck, a Chevrolet with a cracked windshield and bald rear tires. He asked the motor sergeant a simple question that had no acceptable answer. If we go to war tomorrow, how many of these trucks will make it to the port? The sergeant, a veteran of the Pancho Villa expedition who understood military logistics, replied honestly, "Sir, maybe half, and that's if we're only driving to the coast." The United States Army in September 1940 owned approximately 13,000 motor vehicles of all types. The German Wehrmacht, which had just conquered France in 6 weeks using mechanized blitzkrieg tactics, operated over 600,000 military trucks. More troubling than the numbers was the fact that American military trucks didn't exist as a standardized design. The Army drove whatever civilian trucks could be requisitioned, modified with makeshift bed and trailers, maintained with parts scavenged from commercial suppliers, operated by drivers trained on vehicles they'd never see again in combat. France had fallen because German armor moved faster than French armies could respond. Those German tanks hadn't driven themselves to the front. They'd been carried on trucks, supplied by trucks, supported by trucks, and when they broke down, recovered by trucks. Mechanized warfare meant truck warfare. Without reliable military trucks in vast quantities, the United States couldn't field a modern army regardless of how many soldiers it drafted or how much equipment it manufactured. This is a documented story of how American automobile manufacturers, given an impossible deadline and contradictory specifications, created standardized military trucks from nothing and produced them in quantities that eclipsed all previous manufacturing achievements. The truck problem facing America in 1940 was far deeper than simple numbers. It was a crisis of standardization, supply, and strategic understanding. The United States had never fielded a mechanized army. The country had fought World War I using horses, railroads, and whatever civilian trucks could be impressed into service. The few purpose-built military vehicles that existed in 1918, the Liberty trucks, Class B standardized military trucks, had been designed by committee, produced in limited numbers, and scrapped after the armistice when Congress slashed military budgets by 79%. Through the 1920s and 1930s, the Army bought small quantities of commercial trucks as budgets allowed, modifying them minimally for military use. By 1940, the result was chaos. The motor pool at Fort Benning typified the problem. 63 trucks represented 18 different manufacturers, 27 distinct models, and required parts from 43 separate supply chains. When the Quartermaster Corps conducted readiness assessments in early 1940, they discovered facts that terrified military planners. The average military truck in Army service was 7.3 years old. 31% were over 10 years old, well past normal service life. 47% had odometers exceeding 80,000 miles in an era when most trucks were designed for 50,000-mile lifespans. 62% required major mechanical repairs that couldn't be performed because replacement parts were no longer manufactured. The civilian companies that built these trucks had either discontinued the models entirely or changed designs so thoroughly that parts weren't interchangeable. A transmission from a 1938 Chevrolet wouldn't fit a 1936 Chevrolet. An axle from a 1937 Ford wouldn't fit a 1935 Ford. Engine blocks, frames, wheels, tires, every component was unique. Field maintenance was impossible. When trucks broke down during maneuvers, they were abandoned or cannibalized for parts to keep other trucks running. The German army had solved this problem in the 1930s through standardization. Beginning in 1933, the Wehrmacht established strict specifications for military trucks and limited production to a small number of approved manufacturers. By 1939, German forces operated primarily 5 standard truck types. Each type used interchangeable components within its class. All used standardized 24-volt electrical systems. All accepted standard Wehrmacht trailers. All met identical performance specifications for speed, range, and payload. A German motor pool might have 300 trucks, but only 5 types to maintain. Parts were interchangeable. Training was standardized. Supply was simplified. When France fell in June 1940, American military observers filed detailed reports on German logistics. The speed of the German advance, they noted, depended entirely on truck mobile supply columns that kept pace with armored spearheads. German panzer divisions consumed enormous quantities of fuel, ammunition, food, and spare parts. Without continuous resupply by truck convoy, the advance would have stalled within days. One report from Major Bradford Chenoweth stated it bluntly. The German army is not a tank army. It is a truck army that uses tanks for breakthrough. Without their trucks, the tanks are immobile sculptures. President Roosevelt, reading these reports in July 1940, understood the implications. He called a meeting of his military and industrial advisors and posed a question that would define America's war preparation. How many trucks does the Army need, and how fast can we build them? The answer from the Quartermaster Corps was staggering. To equip the planned army of 2 million men in 89 divisions, the United States needed approximately 650,000 military trucks of all types. Current inventory, 13,000, most unserviceable. Required production, 637,000 trucks. Time available if war came in 1942, as planners assumed, 18 months. The American automobile industry in 1940 produced approximately 4 million vehicles annually, but nearly all were passenger cars. Total truck production across all manufacturers was approximately 750,000 units per year, and those were commercial trucks designed for urban delivery, farming, and light hauling. Converting that production to military specifications while simultaneously expanding capacity will require a transformation of American manufacturing unprecedented in scale and speed. In August 1940, the Quartermaster Corps, working with the Automotive Committee for Air Defense, established a military truck classification system that would govern all subsequent production. Quarter-ton 4x4, the Jeep Light Reconnaissance Vehicle. 3/4-ton 4x4, Dodge WC Series, Weapons Carrier and Command Vehicle. 1.5-ton 4x4, Dodge WC Series, Cargo Truck. 2.5-ton 6x6, GMC CCKW and Studebaker US6, Standard Cargo Truck. 4 to 5-ton 6x6, Heavy Cargo. 6-ton 6x6, Heavy Cargo and Recovery. 7.5-ton 6x4, Semi-tractor for heavy hauling. Each classification would have a single approved design, licensed to multiple manufacturers for mass production. The specifications were extraordinarily demanding. 4-wheel drive or 6-wheel drive for off-road mobility. Ground clearance exceeding 10 inches. Fording depth of 30 inches minimum. Operational temperature range from minus 40 degrees Fahrenheit to plus 130 degrees. Capable of towing loads equal to vehicle payload. Built using standardized components across manufacturers to ensure supply chain resilience. These requirements eliminated most existing commercial truck designs immediately. The contract for the most critical design, the 2.5-ton 6x6 cargo truck, went to General Motors. GMC Truck and Coach Division in Pontiac, Michigan, received the development contract in October 1940. The GMC engineering team, led by Chief Engineer Ormond E. Hunt, started from zero. They designed a new frame using double-channel steel rails. They designed new axles with hypoid gears for higher ground clearance. They designed a new transfer case with high and low ranges. They designed a new engine, the GMC 270, an inline-six producing 93 horsepower, specifically for military use. The first prototype, designated CCKW, rolled out in March 1941. The designation indicated design parameters. C model year 1941. C conventional cab, K-driven front axle, W-driven rear tandem axles. The CCKW underwent brutal testing. Engineers drove loaded trucks through swamps, forded rivers where water reached the hood, climbed 45-degree grades, drove 500 miles cross-country without roads. Everything that failed was redesigned. By June 1941, the CCKW met every specification. The Army approved it for production. Then came the hard part. GMC's Pontiac plant could build approximately 200 trucks per day. The Army needed 500 per day from GMC alone. Between July 1941 and March 1942, GMC constructed a new manufacturing complex covering 123 acres under roof, employing 37,000 workers at peak production. The plant contained 12 2,000-ton presses for frame fabrication, precision machining centers for axle production, dedicated engine assembly lines, and final assembly moving lines. By March 1942, GMC hit the target of 500 trucks per day. By December 1942, 850 per day. The War Department licensed the design to multiple manufacturers. Chevrolet built trucks at plants in St. Louis and Flint. Studebaker Corporation built a modified version designated the US-6, specifically designed for export to the Soviet Union under Lend-Lease. Studebaker incorporated modifications for Soviet requirements: simplified cab design, metric fasteners, strengthened frame for overloading, improved cold weather starting, modified electrical system compatible with Soviet military radios. Between 1942 and 1945, Studebaker produced 152,000 US-6 trucks, of which over 100,000 were shipped to the Soviet Union. The impact of standardization became apparent immediately in training. Before standardization, drivers learned on whatever trucks were available, often obsolete civilian models. After standardization, driver schools used the same CCKW trucks soldiers would drive in combat. Every driver graduated trained on the standard truck. Mechanics faced similar transformation. Before standardization, they needed to know dozens of different vehicles. After standardization, mechanic schools focused on 4 primary types. A mechanic who understood the CCKW could maintain any 2.5-ton truck in the Army, whether built by GMC, Chevrolet, or Studebaker. The critical achievement was complete parts interchangeability. A transmission from a GMC CCKW bolted directly into a Studebaker US-6. An axle from Chevrolet fit a yellow truck and coach vehicle without modification. This required extraordinary manufacturing precision. Gear teeth and differentials required precision grinding. Axle shafts needed machining within 0.005 inches. Frame holes for body mounting had to align within 1/8 inch across manufacturers. The War Department established the Automotive Council for war production to coordinate standards. When GMC discovered their differential gears required modification for proper meshing with Studebaker gears, all manufacturers adopted the modified specification immediately. The proof came in North Africa. When American forces landed during Operation Torch in November 1942, they brought 8,000 CCKW trucks. Within weeks, hundreds were damaged. Repair depots began receiving trucks from multiple manufacturers. Mechanics pulled transmissions from GMC trucks and installed them in Studebaker trucks without modification. They swapped axles between Chevrolet and GMC vehicles. Everything fit. Everything worked. A maintenance report from January 1943 stated, "Complete interchangeability of components between manufacturers has been demonstrated under field conditions." The scale of production between 1940 and 1945 was unprecedented. Total military truck production, all types, 812,000 vehicles. 2.5-ton 6x6 cargo trucks alone, 562,000 units. This wasn't just assembly. These were physical vehicles, each weighing 5 to 7 tons, each containing thousands of precisely manufactured components. The raw material consumption was staggering. Steel for frames and bodies, 3.2 million tons. Rubber for tires, 7.3 million tires requiring 290,000 tons of rubber. The rubber shortage of 1942 nearly derailed production entirely. Japan's conquest of Southeast Asia cut off 90% of Allied rubber supplies. The War Department responded with tire rationing that reduced civilian consumption by 73%. Synthetic rubber plants increased production from 15,000 tons in 1941 to 780,000 tons by 1944. In June 1942, General Motors briefly considered halting CCKW production due to tire shortages. Only the arrival of synthetic rubber shipments in August allowed production to continue. The trucks reached combat in every theater. In North Africa, CCKW trucks supplied Patton's columns across Tunisia. The truck's six-wheel drive allowed them to operate in sand where German two-wheel drive trucks bogged down. In Sicily and Italy, trucks navigated mountain roads never designed for motor traffic. The infamous Route 6 from Naples to Rome saw continuous truck convoys throughout 1943 and 1944, supplying the Fifth Army's advance. The CCKW's low-range gearing allowed it to climb grades exceeding 30% while fully loaded. The Normandy invasion in June 1944 brought 41,000 vehicles ashore in the first 2 weeks. The Red Ball Express, established in August 1944, demonstrated what mass truck power could achieve. At peak operation, 5,900 trucks carried 12,000 tons of supplies daily from Normandy ports to forward depots, a distance exceeding 400 miles round trip. Drivers operated in two-man teams, alternating shifts to keep trucks moving 24 hours per day. In 3 months, the Red Ball Express delivered 412,000 tons, sustaining the Allied advance across France. In the Pacific, trucks faced jungle conditions that destroyed vehicles designed for temperate climates. The CCKW, with sealed electrical systems and corrosion-resistant components, survived. The front-mounted winch, 9,000-pound capacity, became essential. Trucks pulled themselves through swamps and hauled supplies to positions unreachable by any other means. The Soviet Union received 152,000 Studebaker US-6 trucks under Lend-Lease. These became critical to Soviet logistics during the massive offensives of 1944 and 1945. Marshal Zhukov acknowledged in his memoirs that American trucks enabled Soviet operations, stating, "Without American trucks, we would not have had the mobility to conduct the operations that destroyed the German army in the East." By 1945, the American military operated more trucks than all other combatants combined. Germany ended the war dependent on horses, using over 2 million for supply transport because truck production couldn't replace losses. The Soviet Union depended on American Lend-Lease trucks. Britain produced trucks sufficient only for British forces. Japan never developed adequate truck production. Only the United States achieved true truck-mobile logistics. After the war, production ended abruptly. Hundreds of thousands of trucks were declared surplus. The CCKW, called the Deuce and a Half by soldiers, became legendary. The Korean War briefly brought the CCKW back into production in 1951. The M35 truck that replaced it in the 1950s was essentially an updated CCKW. The design worked so well that fundamental changes weren't necessary. Today, military trucks follow principles established in 1940. Standardization, parts interchangeability, rugged capability, all-wheel drive. The family of medium tactical vehicles introduced in 1991 is a direct descendant of the CCKW. When George Patton stood in the Fort Benning motor pool in September 1940, he couldn't have known that within 5 years, American factories would produce more military trucks than the rest of the world combined. 562,000 2.5-ton trucks. Standardized, reliable, unstoppable. Germany's Blitzkrieg succeeded initially because of trucks. It failed ultimately because Germany couldn't produce them in sufficient quantity. America won because it could. Not the most advanced technology, not the cleverest tactics, but the simple ability to build more trucks than the enemy could destroy. America had no reliable military trucks in 1940. By 1945, American trucks had driven the road to victory on 3 continents.